Hello, and welcome to the Gaming with Science podcast, where we talk about the science behind some of your favorite games.
In today's episode, we're going to discuss compounding by greater than games. Hey, I'm Brian.
This is Jason.
And welcome back to the 5th episode of Gaming with Science. Today we're going to talk about Compounded, the peer-reviewed edition, which is an interesting chemistry game created by Daryl Lauder. But before we get into that, Jason, do you have any science topics for us to talk about today?
So I do have one, and this one's close to my heart. It has nothing to do with chemistry. Sorry. So I was, again, at a conference recently. Actually, we're going to have a bonus episode out probably next month, the Maze Genetics meeting. So the big meeting for all the corn geneticists, a lot of us based in the US, also some outside. But I was talking to one of the USDA researchers there, Sherry Flint Garcia, who I've known for a few years. And I love her work because she's got these projects that are looking at corn from a human consumption point of view. So basically, corn that people eat. This is one thing that comes up a lot. We grow a lot of corn here in the US, and almost none of it goes to humans. Most of it goes to animal feed, and a small amount goes to ethanol, and then some of it, a little tiny bit, gets made into like tortillas and chips and sweet corn and stuff. But she has all these projects that are looking at corn from the human perspective. So she's been working with local groups to do tortilla making quality on corn for a while. I believe she's working with one group now on whiskey and how to make that. And then the one that I'm really cool about, she's doing a big evaluation of like 1,000 traditional varieties of corn from the US just to evaluate like how they perform, because people haven't looked at this information in decades. But there's things that are like they have different flavor profiles, they have different use profiles. You know, for being one of the largest producers of corn in the world, the US we don't appreciate it all. I mean, you go down to Mexico, they appreciate their corn. I mean, corn is big deal in Mexico. You don't mess with their corn. But here in the US, it's like we don't care. And that's kind of sad. So I'm glad that there's someone doing that now. And I hope they come out with some really cool stuff out of there. I hope they get some good evaluations. They can find some varieties that work well and that people can use for actual eating varieties.
I really was hoping you were going to say she was doing a big study of popcorn varieties.
No, she doesn't do popcorn, although I think she has a collaborator who's actually specifically looking at all the popcorn varieties in there. Yeah, we're both plant people. We could go off on this for a full hour in terms of all the varieties and their adaptations and stuff. And I mean, I love genetic diversity among plants, and we could talk about that all day long. And that's not what this podcast is about.
No, well, not this particular podcast. Maybe we'll find a game that will give us a better excuse to talk about that. But for now, I think, let's get back to talking about board games.
Yeah, we need to see. Is there any science in Agricole? I actually haven't played it.
I don't know. I know you put it on the list. I guess we can find out. Probably not, but we'll find out someday. So we want to talk about this game?
Sure.
Okay. So we are going to talk about specifically Compounded, the peer-reviewed edition. And this was released last year in 2023. Designer is Daryl Lauder at Greater Than Games. The original version of Compounded was released 2013. So it was a 10-year span. There were a couple expansions in there, including like a radioactivity expansion. I didn't get a chance to look at those. Now, one of the things that I was trying to figure out, and that I have tried to figure out in the past, is what inspires a board game designer to want to make a science-based game. So, for instance, the creator of Wingspan was an avid birder, and the creator of Stellar Horizons was an MIT. What was his major? His
graduate degree was in like human space exploration, and then he went off to work at SpaceX.
So the connection is obvious, right? Well, I actually had to dig on Daryl Lauder, who unfortunately didn't have a Wikipedia page, so it made it a little challenging. I listened to an interview that he gave, and like eventually I was able to find in a blog on the Greater Than Games website that he has a theater degree, and like went back to get in graphic design and didn't do that. So like, to be honest, after all my digging, I don't know what inspired Daryl Lauder to design a chemistry game. It's really unclear to me. Maybe that comes through a little bit in the design of the game a little bit. I don't like being critical of games, but there's got to be some criticism of this one, I think.
Yeah, we'll see. You talk a little bit about this. I may have some pushback on that, but we'll see. But there's enough in here that either he talked a lot with people who actually do chemistry, or he had some background, even if it was just an undergraduate laboratory. Actually, that would explain why fire plays such a big role in this game.
I absolutely agree, and I do want to talk about that. I can tell that a lot of careful choice went into balancing and selection and how this game was designed, but unfortunately, almost none of that is in the metaphor of the game. So that's where we're kind of got to talk about things later. But okay, so what is this game? What does it look like? If you want to play Compounded, what are you going to do? It is a game for 2 to 5 players. Plays in 45 to 70 minutes. That sounds about right to me. The suggested age is 14 and up. Now, this is not an overly complicated game, so that age seems high, but I think that maybe the sabotage trader mechanics might just be something that maybe a child maturity level could be the suggestion for 14 and up, as opposed to the complexity of the game. There's a lot of ways to mess with other players.
I've got to say that as someone who likes messing with other players, there's not that many ways of messing with other players. There's a few. But
we just didn't do as much of it. That's all. Like I think that there's a whole you could play this game as a pure troll if you wanted to, and just play it to be destructive and just destructive. You wouldn't win the game, but maybe I don't know. Maybe there's a balancing issue there, potentially. So what does this game look like? So you'll open this up. You have a full copy of the periodic table. So the periodic table is basically just your score tracker. It also has some places where you can do some actions, like activate various sciencey tools like Bunsen burners or lab notebooks and stuff like this. There's a lot of like science theming in this game. The players are going to have these little player mats. They've got 4 little tracks on them. And then you're going to have a grid of chemical cards, compound cards. And each of these cards has between 2 and 6 different atoms on it, and 2 to 4 different types of atom. You'll lay these out in a grid of 4x4 if you're in a 3-player game or more. And then you've got this little bag of these beautiful little crystalline little plastic things that are supposed to represent different types of elements like hydrogen, and oxygen, carbon, nitrogen, calcium, which we'll come back and talk about that, and sulfur. And your little track, you've got 4 of them, and it gets to decide like, okay, how many of the little elements do you get to pull out of the bag? How many can you keep? How many can you place out onto the cards? And then your last track is how many actions do you get a turn? And this is a victory point game. You just collect points from the face value on the cards. You get some points for advancing your track. I think that was it. Seem right to you?
yeah, that's it. If there's other ways of getting points, we didn't play with them, but I don't think there are.
Okay. So the other mechanic is after you complete a compound, you get to score the points. You take a new card out of the deck and you place it down, and it's either going to be a different compound or it's going to be a fire. And if you have a fire, it can catch fire to the surrounding cards. If they run out of places for fire to be, they will explode and scatter the elements to the surrounding card. All of the players have a fire extinguisher. It's everybody's responsibility to put out the fires when they happen, because, if you don't, then you're going to have things blow up.
We got to say, this is one of my favorite little mechanics of the game. It doesn't have to be there, but it's a fun bit that sometimes you're doing organic chemistry, things just blow up.
Yeah,
that happens, which is why everyone has a fire extinguisher and why half the compounds catch on fire. I do like that when they catch on fire, their point values go down because there's a real reason why you want to put out the fire. And then, of course, you can use this a little maliciously because there are some tools that let you set fire to other people's compounds they're in the middle of building and possibly blow them up.
There are some compounds where when you score them, they just catch fire no matter what because they're just that flammable. And like it's as if a fire had occurred. There is one of the tools, the Bunsen burner, where you could literally set fire to any compound you want of somebody else. You can set fire to water.
Which I think mechanically is just you're boiling it off.
I think they said the mechanic is that you've contaminated their sample in some way.
Okay.
To what you've put something into it that allows it to catch on fire, just like the rivers in Cleveland, right? Those are the basics of the game. Another interesting element to this is that this is the only game we've played so far where, as the players, you are supposed to be taking on the role of a scientist, of a researcher. And the original conceit was you are all scientists in the same lab competing to be the lead scientist, which Jason and I are in labs. That's not how that works, but okay.
You're competing to be the lead postdoc. Let's call it that. Like the lead scientist doesn't actually do research anymore. They're up managing and writing grants and supervising people. All the people doing the fun stuff in the lab, they're the postdocs and the grad students and the research scientists.
Yeah, I think as somebody who does research, in my head, I was like, oh, I'm the lead research and I'm collaborating with other labs, not individuals in one lab. But anyway.
I think one thing in there, so the one thing to point out is the tracks, the 4 tracks that the player board has. So as you go up in the tracks, they not only get you points, but they get you resources you need. So there's a limited number of the little atoms you can draw each turn, how many you can keep, how many you can play, that sort of thing. And as you move up in the tracks, you get access to more. So there's a little bit this tension because if you go after high value compounds, then you get a lot of points, but you don't move your tracks very much. And so you have limited ability to do more. Whereas if you go after a bunch of cheap compounds, you're not getting many points, but you're improving your ability to do other things later. And there's a little bit where the compounds are like solids or liquids or gases, and that determines which track you can move up. And it's a nice little touch. I like that.
Yeah, the game really did have a lot of care and design that was put into it. There's a lot of strategy. There's a lot of different ways to play. You can work together. You can work against each other. I mean, it's a good game.
Yeah, you even have the expansion or the component where there's the mega compounds that are designed for two players to work together on them.
Oh, yes, very good point. Thank you. That is the key mechanic of the peer-reviewed edition is you have these double-sized cards that two people could work on together. Those can range up to 20 atoms and be worth up to 38 points.
Which is like half a victory condition right there.
Yeah, pretty much. Now, one thing about those large cards, the little cards they are real chemicals, real chemical names. They have little facts about each of the chemicals. The giant size cards have some really interesting compounds on them, but they're missing the little facts. I don't know if the assumption is, well, that people will just Google it or something. Like nitroglycerin is a very charismatic compound. I think everybody knows what nitroglycerin is. It's extremely explosive. Dimethyl trisulfide, which I know personally because it's the stinky compound that's made when garlic breaks down, which is something I study. Trimethylamine, which is the odor that we would associate with fish. These are interesting chemicals, but there's no little like kind of fact about what these do. Anyway.
Well, that's a missed opportunity.
Yeah, I think so. A little bit. That's the basics of the game. Let's try to talk about the science here. And this, I am going to consider this a little challenging because basically what I'm going to try to do right now is speed run chemistry. Okay. As I see it, the things to talk about here, the sort of the core science concepts that are in compounded, at least tangentially, are atoms, elements in the periodic table, compounds, what is a compound and what is a chemical bond. And then I also spend a little bit of time like, what makes something flammable? Or more specifically, combustible, since it is such an important part of the game. And maybe a little bit on phase of matter. I don't know how much we want to get into that. I also thought it would be worth talking a little bit about the depiction of research and scientists in this game. Because again, this is one of the only games we've had where scientists are part of the game. So we can talk a little bit about like some of the depictions, what we think they got right and what maybe we think, nah, maybe not so much. Let's get started with this. Again, this is my crazy, here's chemistry in a nutshell. So what is an atom? An atom is made of three different particles. You've got a proton with a positive charge, a neutron that pretty much is just there to kind of help the protons stick together, and an electron. So the protons and the neutrons are in the nucleus. They don't really do very much. They're not really that interesting. All of the action is happening with the electrons that kind of orbit around that. Not really in orbit, more of like a shell. It's all quantum-y stuff, and I don't really want to get into it.
Yeah, this is the sort of thing where you could spend an entire like undergraduate degree really understanding what's going on here and still not be deep in there. Now, that said, the nucleus, the protons and the neutrons are extremely interesting for nuclear chemistry,
yes,
which is where radiation and nuclear bombs and all that stuff happen. Stellar fusion, that's what powers the sun. But ordinary everyday chemistry, like we do in compounded, that's all with the electrons.
Yeah, for sure. Like all of the interesting stuff that happens with chemistry in our day-to-day lives, it's all about the electrons, right?
So with atoms and trying to build an atom, there's kind of two forces at play that we really want to care about, at least for today's episode. One is charge. So protons are positively charged, electrons are negatively charged. So the first thing you want is you need basically the same number of protons and electrons, so the atom itself is not charged. That makes things happy. The atom doesn't want to be charged, usually. There's a second thing that modifies that, though, and has to do with just the electrons. This is quantum stuff. It has to do with how they form groups and the electron shells and stuff. And we're not going to go into that because that's very complicated. But basically, if you have certain numbers of electrons and they fill these little shells they're in, a full shell is more stable than a partially full shell. And so sometimes that will overcome it. So there are some atoms where they actually want to gain an additional electron or lose an electron because that leaves them with completely full shells instead of partially full shells. And that sort of trading of electrons is actually what forms all sorts of chemicals and bonds, as essentially the nuclei are either sharing or donating or stealing electrons from each other to make sure they're all happy and have the right number of electrons in their shells.
Yeah, for sure. So the analogy that I like for this is I think it's usually called the bus seat analogy, but I actually kind of like the train car analogy. If you imagine when people are sitting on the bus, the electrons don't want to sit with each other. They'll sit in the open seats first until there are no more open seats, and then they start pairing up and sitting in twos. As the atoms get bigger, you kind of hitch new train cars onto the back of the train that have more seats, but they're still kind of going to fill up in that basic way. An atom is an element based on having the number of protons. So like hydrogen's got one, helium's got two, and you just keep going up this list. As you make the bigger atoms, you're adding more places for electrons to go. And how many unpaired electrons are sitting in those outermost seats, that's kind of determining what kind of chemistry this is going to be able to do. And that's actually the basis of the periodic table, is as you're filling up these electrons, you kind of come back around and you do the circle again, and now you're repeating the same pattern of unpaired electrons. So everything in a column of a periodic table sort of has similar chemical properties to it. In fact, like it's a table, but really it should be like a ring where they kind of like connect back around together as like a spiral. I was watching a video by Hank Green. That was one of the original proposals. They didn't publish it because the publisher couldn't figure out how to publish a spiral periodic table. So Mendelev's became more popular. So actually, this is the thing. Like the periodic table is based on every time you go up one proton, that's a new element, and you just keep going all the way. So unfortunately for science fiction authors, like if you want to discover a new element, there's nowhere for it to go but at the end. Like we know all of the elements, it's just adding protons until eventually get to the end. And the ones at the end are so big and so heavy that they can't hold together. They're all radioactive and they just decay. So we might find new compounds, but we're probably not going to find any new elements at this point.
Yeah, I like the way Mass Effect got out of that. They found element 0. I don't know how that works, but that's what they found, and that's what makes all the science magic in that video game series work.
Something less than hydrogen.
Something.
Okay. That's funny. As you pointed out, so that is the basics of an atom, an element. The elements are just going to have a set number of protons, and how many electrons they have that want to have partners is based on how we're going to get our bonds. So let's talk about bonds. Like, what does that go? So you said it's about sharing or trading electrons, right? Electrons want to be in pairs. An ionic bond is something like sodium chloride. In that case, there's no sharing happening.
Table salt.
Yes, table salt. Sorry. The electrons get stolen by one atom from the other, and that's the preference. And those ends up with, you get charged. That's where you get like ions and stuff like that.
Yeah, and that usually only happens with the ones that are on the far left and the far right of the periodic table, because they're the ones that are closest to that stability point. So it's easier for them to just get rid of one or gain one, and suddenly they're perfectly happy.
And those are the so in a board game context, that's the competitive elements. They don't then we've got our organic compounds, are ones that will form covalent bonds. They like to share. Those are our collaborative board gamers. In that case, instead of, they actually don't trade, they kind of will use the same ones together. And that's where a lot of the really interesting chemistry happens, because they're very stable. They're very happy to just kind of sit right next to each other and share those electrons. It kind of keeps them into a tight connection with each other. So this is so things like carbon have 4 unpaired electrons, so they can bind to 4 different things. So, and actually a lot of let's talk about this. What is an organic compound?
From chemistry perspective, it's something that involves carbon. This is completely different from organic produce, which is something that irked me for many years. It's like, all produce is organic, it's all carbon-based. Stop using that. But that's a personal pet peeve. I have gotten over it and accepted the fact that the label means 2 different things in 2 different contexts.
So, for instance, water is not an organic compound. Water does not have carbon in it. So carbon can bind with 4 things, nitrogen can bind with 3 things, oxygen can bind with 2, hydrogen can bind with 1, sulfur can also bind with 1. And then we've got our weirdo in this game, which is calcium, right? So I was looking at these and the way that they're colored and the balance and everything, and I'm pretty sure I know part of the inspiration for why Compounded uses these. I did ask, I think this might only be something at the college level, but Jason, you've, I assume, played with a ball and stick chemistry model in college?
Yeah. You can get them at bookstores or get them online or whatever.
So these are the little balls. They've got little sticks. They've got the right number of holes. Like carbon, you can shove 4 things into it. Hydrogen, you can only do 1. The distribution of elements that you have in Compounded is very, very close to the distribution that you would have in one of those chemistry kits. And actually, the colors are the same too, for the most part. There's sort of this mnemonic thing where like hydrogen's a clear gas, so it's always white, and oxygen's in our blood, so it's red, and nitrogen is in the atmosphere, so it's blue. Carbon is coal, so it's black, and sulfur. Why is sulfur yellow? I mean, sulfur makes various yellow compounds.
I mean, elemental sulfur is yellow. Why is calcium green?
Well, that's a good question because actually, in your typical chemistry kit, it wouldn't be calcium, it would be chlorine or something like that, or fluorine or something like that. I did check this as well. There are versions of this sort of scheme of sort of color mnemonics where calcium would be green. So, organic compounds, like you said, is carbon, anything with carbon in it. The origin of the term comes from, oh, these are the compounds that we find in living things, right? I mean, that's kind of where it originally came from. Um,
Back
but
when they thought that only living things could make it, there's some
right,
special life force that allowed it. And then people figured out organic chemistry and it's like, oh no, we can make these too.
yeah,
They
100%.
can be really annoying to make sometimes, but yes, we can make them.
Yeah, living things are really good chemists. It's really hard to do in a test tube, but can be done easily in a body. Well, maybe easy isn't giving them enough credit.
I mean, given the Rube Goldberg-like contraction that is a living cell, I'm not sure easy applies here. They're very good at it because they've had 4 billion years to get good at it. But
Okay, okay.
I mean, if you actually figure out everything that's involved in making
Yeah.
even simple compounds, it's like, oh, no. This is a highly tuned system. But easy is not it.
Okay, that's fair. That's fair. So calcium is the oddball. Calcium is not something that can make, it's not one of the ones that shares. Calcium's actually a metal. It's like way off to the side and it doesn't participate in covalent bonds. Now, I was thinking about this and what you would typically see in a chemistry kit would have been phosphorus, not calcium or chlorine or something like that. A lot of the compounds in compounded are these sort of nice organic chemicals with carbon in them. Phosphorus would have been typical, but phosphorus typically doesn't hang out by itself. It usually has a bunch of extra oxygens in there because you usually have phosphate. It's like a phosphorus and a couple of oxygens, usually three. And then that's what gets stuck onto other compounds. So I imagine it was literally a game balancing choice. You don't want to use phosphorus because, well, you're never going to have it on its own. The compounds are going to be too big. And there was this clear choice of making it between 2 and 6 atoms on each compound card. So phosphorus just didn't make sense. So, okay. So here's where I actually spent a little bit of time trying to figure out now what makes something flammable, because this was a big part of compounded. And that, as I don't know, that's more complicated than you would think. In a sense, it's not. So combustible is a much more easy thing to understand. Something is combustible when it can react with oxygen and release energy in the form of heat or light. So anything that can react with oxygen would be considered combustible. Now, what makes something combustible in that sense is, so for instance, wood is combustible. Once you get the reaction going, it produces more heat and light and then creates more heat and creates a chain reaction, sort of reacting with more compounds. And that's what causes things to burn.
And going back to the reason behind this is because oxygen is very good at taking electrons from other things. It wants to share electrons, but it's very good at grabbing onto them and holding them tightly. Arguably one of the best atoms at doing that, which is why it's essentially the chemical dead end of so many things. Once you react something with oxygen, you have to pour energy into it to get it back out.
Well, so, okay, that's what makes something combustible, something that can react with oxygen, release energy, which if you're releasing energy, it means it's like a preferable state for the chemical to be in. It's like things are always wanting to go towards the lowest energy state. Flammable is a little weird. Flammable is just like how volatile something is, and that's very dependent upon pressure and temperature and everything else. Something's flammable where you put an ignition source in it and it just goes like that's flammable. So you can be combustible and not flammable. It gets really complicated. It's like vapor pressure and all this stuff that we don't really need to get into. I think, and then there's also like explosive, which is about producing gas. It's too much. It's too much to get into.
Okay, but basically for flammable, it has to be able to evaporate.
Yes.
To get into the air
Exactly.
and essentially be pre-mixed with oxygen. So all you need is a spark or a heat source to do it. Whereas the wood is not going to evaporate. It's just going to sit there.
But interestingly, to get wood to catch fire, you do have to go through a process called pyrolysis, where basically you are releasing flammable gases from the solid. Like it has to be able to mix with the oxygen. So it has to be able to vaporize in some way to be able to be flammable. that is the basics of the science. Hopefully, we did a good job of that. I think we did the best we can considering we did it in what, 15 minutes, 20 minutes?
There are plenty of YouTube's videos on about basic chemistry, but there's a lot of ground to cover here because this is how atoms form bonds.
Yeah.
Which is chemistry,
yes.
basically. That's the entire field of chemistry right there, is atoms forming bonds.
There is legitimately a great short crash course on chemistry. It's a series by Hank Green. If you're curious, I would suggest watching it. It's got really good production values. It's a lot of fun. It's Hank Green. He's a great science communicator. Yes, let's talk about how that science is represented and compounded. It's not really.
Well, here, I'm going to push back.
Okay.
I'm going to say it's subtle.
Okay.
Like, and that's the point. Like, you talk about a science game. This game is not meant to be a science communication game. It has the science skin painted off it, but there are little nods. Like the one I noticed the first time we played, when you get the little plastic bits of the atoms. So half of them are clear and half of them are opaque. And it turns out the clear ones are all the gases and the opaque ones are all the solids, at least at normal room temperature. The fact that like things are flammable. Well, only some of them are flammable, and they are presumably the ones that are actually flammable.
Yes.
You have the solid liquid gas phase, which determines which of your tracks you're able to move up. It's like they're there, but they're subtle. This is not Wingspan. This is not trying to teach you all sorts of chemistry facts. They're there if you go digging, but they're not there if you don't care about them.
Which I guess is kind of, I don't know, maybe that's kind of my point. You don't accidentally learn things playing compounded. Maybe you do. Maybe I'm being too harsh. Again, I think that there's a way to do it where, okay, like, again, I hate to constantly be comparing to Wingspan. It's going to be hard not to. I apologize if this is already turning into old for people who are listening to this. You can't play Wingspan and not learn something. You just can't. It's impossible. But no, you're right. There was a lot of nods here. So for instance, the coloring. Right, that consistent elemental coloring. Now that is something where you could start to intuitively, if you had played compounded, it's like, oh, it's carbon, right? Because it's consistent, you've gotten used to it, it's always depicted. They are real chemicals, right? But nothing about like how you play the chemicals onto the cards. They're in the terms of designing this game, I am certain a lot of care went into the selection of the appropriate chemicals with the right balance of elements, the correct structures, balancing the point values, the flammability, the phases of matter, all of that. I'm sure there was a ton of effort. The specific choice of calcium over phosphorus or chlorine or something like that, so that you could have smaller ionic compounds instead of just these large organic compounds. All of that was behind the scenes. The problem is I don't know how much of it is in the front for the player to kind of absorb. So that's really where my criticism lies.
Yeah, and that's probably a design choice. I mean, that's one of the knobs you get to tune as a designer, is you choose how upfront am I going to make this, how behind the scenes, like what do I want the focus on to be? And the game designer here just chose to have there be science in there, but have it be a subtle. It's a background thing. It's not in the foreground.
So another aspect of this that I think we should talk about is the depiction of scientists in a game, which we haven't really had a chance to do yet. I mean, Stellar Horizons arguably had more to do about politicians. This, you actually have like scientists. You are playing a scientist trying to discover chemistry, chemicals, compounds, and competing with one another or cooperating with one another in the process of doing that. So a lot of these are just like, the way that the terms are applied don't always make a ton of sense. Your four little tracks on your board are called your experiments, but then they're labeled Discover, Study, Research, Lab, which I'm not really sure. Like, there is sort of that standard process of the scientific method of like hypothesis, testing, research, and then I guess we would consider publish to be an important part of the process. You got to tell people what you found. So, that's fine. I mean, the player markers are just random pieces of glassware. I mean, that's fine. It's fun to play as a little beaker. This is your Monopoly dog for playing compounded, is getting to play a little Bunsen burner. There is some other weird stuff, I suppose. One thing that caught my attention was one of the things you can get is a research grant. In this game, the research grant just benefits the person who's doing the worst. I can tell you from experience, that's not how research grants work. They do not go to the lab in most need.
Yes, and there are specific funding mechanisms for that, but by and large, like the successful labs get most of the big successful grants, which lets them be successful and get most of the big successful grants. I mean, as in many other things, the rich tend to get richer.
So another big mechanic, a fundamental mechanic of the game is this ability to claim a compound. You said, I am working on this one. And that's it. You say you're working on this one, and your other people then they could work on it if they want to, but they won't derive the benefit. It still is your compound. Now, it kind of works like that a little bit, like, but that's really casual. Like, there are definitely people who will, okay. So in science, we have this process called getting scooped, which I imagine that also happens in like news and any time where you're in a truth-based field. I am studying something. I am working on this really hard. And then I find out just as we're about to finish up our work that someone else has published the exact same observations. Oh no, now they get all the credit and none of our stuff counts. So I can tell you that from a career perspective, getting scooped does suck because of the way we sort of apply credit. And it's like, oh, now that's their discovery. It doesn't matter that we were working on it. But really, scooping is the sign that science is working the way that it's supposed to. It means that you can have people on different sides of the planet not talking to each other, unaware of what the other one is doing, making observations about the world and finding the exact same thing. Scooping is a good thing. It means that the process is working okay.
That said, I prefer in so much as I joke about how much I like messing with other people in games, in real life I like cooperation. And so if I realize I'm working on something similar to someone else, I'll usually try to cooperate with them or at least see how we can carve out our own niches. Now, part of that is because the fields I work in tend to be relatively small. There's not enough space for us to compete with each other. If we compete against each other, everyone loses. There's just not enough grant money flowing around. I've gathered that's not the case for the big money areas. Like human cancer research, I've gathered is pretty cutthroat because there's so much money going around. You can't have 5 or 6 labs all studying the same thing, all racing to get the same new research, the same new discovery out there.
Yeah, that's true. And you're right. I mean, obviously, cooperation, if you work together, you reinforce each other's work. That is the path. It is not the path that is always taken, though. There are definitely people who want the credit.
Yeah. Now I was gonna say the whole way where like you can claim one and then other people can work on it. That seems to me sort of like first authorship. So the way we scientists boost our reputation is we publish papers. And although there's different standards in different fields for exactly what the order of who goes on that paper matters, generally speaking, whoever is the first author gets the most credit. They did the most work. It was their idea, whatever. And so there's actually this thing that when we go to publish, you kind of have to negotiate what order people go in order to make sure everyone gets the right amount of credit. And so that claiming seems to me like, oh, this is the first author on this. Other people can help if they want, but they're the one that's going to get the most credit. I think it'd be nice if there was some mechanic to represent that where it's like, oh, if you assist on this, you get some small amount of points. Like, oh, you get 1 point or 2 points for everything you put on there, while the main person gets most of it. But that would require other things to track it. And so it's not really an easy fix to add to it. But that's how I see that particular aspect of the game.
We need like compounded the collaborative edition.
Yes. Or unfortunately, the competition part does happen. It's like, although it's not good, I have actually heard of scientists sabotaging others' research. This is thankfully very rare. And when it's found out, it is like, that is your way of getting blacklisted in science. Like you do not sabotage other people. You can collaborate, you can compete, you can try to scoop them, but you do not undermine other people's work. And I have heard of some people where this years ago, I read like there was some postdoc where he was just feeling very stressed and pressured. And for reasons I still don't understand, he poured ethanol on his lab mates' cell cultures. So this is how to kill cells.
Yeah.
And he like added it to some of her growing media so it would kill them. It's like, I still don't understand the reasoning why, because as far as I can tell, he was not competing with her. It happens. Now he got found out pretty quickly because ethanol smells very different from normal cell growth media. And they put a camera and they saw it happening. He got confronted, fired, et cetera, et cetera. So like action was taken, like justice was served, but still that wasted weeks at the very least of one person's work, sometimes months. And so this is why we scientists don't have very much when you get down to it. We don't have much money. We don't have that much prestige, most of us. Pretty much all we've got is our reputation and our results. And so we protect those pretty fiercely. And basically, number one way of getting blacklisted as a scientist is to do something to actively harm someone else's research.
But I think that sort of covers the basics of the science that is behind compounded, how compounded addresses it, and kind of like a little bit about being a scientist in a board game like setting and how that's represented. But let's talk about the game itself. Did you enjoy the game? How did you like playing the game? Or what were things you liked or didn't like?
I did. I found it enjoyable. I think it's a fairly straightforward game. At least maybe if we played it more, I'd realize there are like deeper depths in terms of how you can interact with others. But mostly it seems pretty straightforward. It's like, oh, okay, I need to move my research tracks up so I get more resources. I need to acquire compounds as fast as I can so that I get victory points. And I need to do that faster and better than everyone else. And it seemed pretty straightforward to me. But that's my impression so far. Like, there's not an obvious way for there being a bunch of depth to it. It's pretty straightforward. It's a nice light game.
I'm sure there's an optimal way to play that. Well, clearly there is, because I think, again, as has become tradition, I think you completely annihilated everybody on points. So clearly there is an optimal way to play. And one of the things that I noticed is not a single time in all the times that we played did we actually have a fire get out of control, which is a huge part of the game that just doesn't seem to come up very much.
Yeah, I noticed that when we were playing together as families, someone always had a fire extinguisher ready. In part, I think we were so paranoid about a fire happening that if we all ran out, someone would refresh their fire extinguisher to make sure we could handle a fire. And then when you and I played individually, they just, by the way the deck was shuffled, they just never came up.
No, it's a fun game. There's sort of the Catan style trading mechanic, which we didn't get into, where it's like, hey, I'll trade you 2 hydrogen for an oxygen or something like that to try to get on what you're working on. There's plenty of opportunities to sabotage, but I don't know. I guess it just didn't come up that much. Were you sabotaging anybody, or were you focused on just scoring your own points?
I wasn't outright sabotaging. I mean, most of the outright sabotage seems to be you light someone else's compound on fire. Mostly, I was poaching. There were definitely times where someone had partially built a compound and left it open. It's like, oh, I can fill that out. I'm going to grab that compound now. Thank you for doing the preliminary work.
No, it was a fun game. I'm trying to decide, like, on my personal scale. Well, okay, is there anything else you want to talk about the game? I mean, the game is very pretty, for sure. I love the design. The elements are fun. They're in a nice little cloth bag. Daryl Lauder is a graphic designer, and I think that shows. It all looks very nice. I do think that the use of the periodic table as just a score tracker, it makes sense. I don't know what else you would do, but it seems like having a whole periodic table and have that not really matter except as just tracking your scores, maybe a little unfortunate.
Yeah, it is a nice touch that it's a very easy way to know when victory hits, because if you remember the periodic table, there's those 2 lines that are always put down at the bottom. Technically, they belong in the middle, but then the periodic table will be stupidly wide. And so they're always translated down. When you go down there, that's when you trigger the victory condition. It's like the top row is for a 2-player game, and I think the bottom row is for like a 3 or 4-player game. So that's an easy way of tying that table to knowing when to stop.
I just realized the actinides and the lanthanides are basically Hawaii and Alaska on a map of the United States.
Yeah, basically.
You pull them off in their own little separate section because to try to show the whole thing would make it too big. All right. So should we do some scores?
Yeah. And this is an important thing. I realized we've never really defined how we set these scores. So we give these letter grades, but we never really calibrated it. So I wanted to put that out here. At least this is how I do it in my head. Everything starts at a B. And I want to say that because eBay and Amazon and everything have all trained us that anything less than 5 stars is failure. And that's not the case here. No. Things start at a B. And then if you do things well, you go up. And if you do things poorly, you go down. So that's kind of the at least that in my head, that's how I'm assigning these grades. So getting a B is not a bad thing. It's like, okay, you did something, you did it well, that's fine.
It sounds like there's a B in there.
Oh, there will be a B in here.
Okay.
But
how do I do it? I mean, at this point, I think we're sort of establishing the scale as we go. Wingspan's an A, right?
Yeah.
The definition of an A. But I think I think what I'm thinking about it is, I guess I don't have as much of that. I don't have a set starting point, but it's this idea of like, are you going to learn science while playing this game, and how much, right? I think that, again, I agree with you. A C is not bad. If we're going less than a C, that means you're teaching somebody something wrong, but a C is okay. Okay. So what is your score then?
Well, so we do this 2 parts. So let's start with the science part. So I would say the science part of this, I would give a B.
Okay.
It's like it didn't set out to do a bunch of science. So there's science there if you look for it. And if you dig, it's there. And there's little subtle nods to it. And so it's like, okay, it's fine. It's a B. It's like, you're not going to learn a ton of science by this, but the things that are there are correct and they actually fit together pretty well.
I don't like to be critical, but I'm going to give this one a slightly lower grade. I'm going to say a C plus. I think that the idea that you're going to come away from this with chemistry knowledge, I just don't know if that's going to happen. So from that perspective, I think that because this isn't an educational game category, which is a game where you're either intrinsically supposed to be learning something or will learn something like by proxy by playing the game. I just don't know if that's true. And I think maybe for the depiction of scientists kind of being like obviously not informed by talking to people who do science, that kind of bugs me a little bit too. So I'm going to give it a C plus. It's okay.
It's not doing as much as you want it to do.
It's not.
Basically. Okay. And we'll just have to agree to disagree on that.
Yeah.
And again, to everyone, we have a Discord. You can come on and tell us all sorts of ways we got it wrong. Okay, so let's move on to gameplay. So your turn. What do you think of the gameplay? How do you score that?
So in terms of gameplay and fun, I think, well, since we're talking about this idea of what are we basing our scores on, for me, it's how likely am I to want to grab this off the shelf and play when we get together to play? How likely am I to stick it in my car when we go to board game night? And for this, it's like, it's a fun game. Is this the one that I'm going to go to and grab? Probably not. So for me, that's a B, right? I enjoyed playing it. I'm probably not going to grab it off the shelf all that often. So that's that B score.
Yeah, I'd probably give about the same. I may go into B plus range. I thought it was a bit fun. As you point out, I did tend to get a lot more points than everyone else. So I think I hadn't solved the game, but I think I was closer to solving it than most of the other players. And like I like that bit of strategy. It's like, okay, how can I find the optimal move? What is the best thing here? But again, it's not going to be one I grab off the shelf like, oh, I just really want to play this one. So it's like it's me. Like if someone brings this and I play with it, I'll be perfectly happy with that. Mm-hmm. I'm probably not going to seek it out a ton.
So that's compounded. Solid chemistry in the background, probably not going to take that much away from it by playing it, but a fun game. I did enjoy it.
Yeah, no, I liked it. I mean, and if I were a chemist, I would have a copy of this in the lab. I like the little touches, the little subtle nods, like the clarity versus opacity of the little pieces. I mean, I like that there are little science facts. I like that the phases of matter for what you're going to do, that sort of thing. So like they're subtle, but they're there. And I really like that. So one quick announcement before we close, looking forward a few months, this episode is going to drop near the end of May. So if you're going to be going to Dragon Con in Atlanta on Labor Day weekend, I will be there helping out with the science track. Brian may or may not be there. We're still trying to figure that out. But we will be there. Again, check our Discord. We'll be coordinating stuff. We may be doing something for the podcast there. And if not, even if not, then you could always just contact us. We could find some place to meet up. We could play some games or anything like that. So just heads up.
Oh, and one more announcement while we're on that. We're going to take our end of semester break after this episode, but we're still going to have something in the feed for you. So we'll be back in 2 months with another regular episode. All right. And with that, I think we're going to wrap it up. And I hope you guys all have a great month and enjoy the break and the bonus content.
Take care. Happy gaming.
Have fun playing dice with the universe. This has been the Gaming with Science podcast, copyright 2024. Listeners are free to reuse this recording for any non-commercial purpose as long as credit is given to Gaming with Science. This podcast is produced with support from the University of Georgia. All opinions are those of the hosts and do not imply endorsement by the sponsors. If you wish to purchase any of the games that we talked about, we encourage you to do so through your friendly local game store. Thank you, and have fun playing dice with the universe. I have so many notes for this, Jason. You would not believe.
For a game you keep saying doesn't have all that much science in it, you have a lot of research on it.